Hi, this is Mrs. Villette, and this is your video for section 5.3. Go ahead and follow along with your notes packet. In this section, we're going to be talking about polynomials. In particular, a lot of what we'll talk about is vocabulary. So our first vocabulary word is a term. A term is simply a part of an addition problem. Next, we have coefficient. The coefficient is the numerical factor of a term. We usually write that out front. A constant term is a term which is only a number, so it won't have any variables. And finally, a polynomial is a sum of terms involving only variables raised to whole number exponents, that's important, with no variables appearing in any denominator, square root, etc. Let's see examples. So we have a polynomial, 7x to the fifth plus x squared y squared minus 4xy plus 7. This does meet the criteria of always having whole number exponents, and there are 4 terms. I can count the terms looking between the addition and subtraction signs. So 1, 2, 3, 4 terms. The coefficient on 7x to the fifth is 7. The coefficient on x squared y squared is 1. When there's not a coefficient, it's always a 1. The term negative 4xy, its coefficient is negative 4. And the coefficient on the term 7 is 7, but this last one is actually a special case because there are no variable parts, so 7 is called a constant term. So the constant term is a term that's just a number. Types of polynomials. We categorize polynomials based on the number of terms. A monomial, you can think of mono, is a polynomial with exactly one term. A binomial, so bi, is a polynomial. Binomial is a polynomial with exactly 2 terms, and a trinomial is a polynomial with exactly 3 terms. We don't bother characterizing polynomials above 3-term polynomials. We could, we just don't. So let's look at some examples. We're determining whether these are polynomials and if they are, why or why not. So 3x squared plus 2x plus 3. Yes, this is a polynomial. It's a trinomial. It has 1, 2, 3 terms. And it's a polynomial because all of the exponents are whole numbers. This constant term, we'll talk about that. It's a special case. That is a whole number exponent. Something like 1 over x plus 2, that is not a polynomial. Because really, if we think about this 1 over x, that's an exponent of x to the negative 1. So when I write 1 over x, I could really write that as x to the negative 1, and that's not a whole number exponent. That's a negative exponent. Now something like 4 technically is itself a polynomial. It's a monomial because there's only one term, and it's technically 4 times x to the power 0, so the exponent on this term is 0. Constant terms are always degree 0. I'm actually going to talk about degree on this next slide. So for the degree of a term, the degree of an individual term, you're going to take the sum of the exponents on the variables contained in the term. You really only need to take the sum if there's more than one variable. So the degree of a constant is 0. If I look at something more complicated, 5a to the 4th b cubed c, this is degree 8 because we need to remember that that's really c to the 1st. So really I'm doing 4 plus 3 plus 1 equals 8. Now, even though these aren't like bases and I can't combine them, I'm going to add their exponents just for the purposes of determining degree. So we determine degree by the sum of the exponents. So let's look at some examples. We're going to find the degree of each term. 5y cubed is degree 3. Notice the coefficient has no bearing on the degree. 10xy is degree 2. And it's because we're doing 1 plus 1. And 8 is degree 0, because 8 is really 8 times x to the power 0, because x to the power 0 is 1. So constant terms are always degree 0. That was the degree of a term. The degree of a polynomial is a little bit different. So to find the degree, take the largest degree of any term of the polynomial. So for example, the degree of 9x cubed, subtract 4x squared plus 7, it's degree 3 because the first term has degree 3, the second term has degree 2, and the last term has degree 0, and the largest of those numbers is 3. Let's look at the degree of each one of these polynomials and indicate whether it's a monomial, binomial, or trinomial. So this first one, 4x to the 5th plus 7x cubed subtract 1 is degree 5. That's the largest degree. And it's a trinomial because there are 3 terms. The next one is degree 4. It's just a single term, and so I'm adding up the individual polynomial exponents, and this is a monomial. So single term polynomial. And then the last one is degree 3, and this is a binomial. A lot of this vocabulary, it's a lot right now, but it is important that you understand this vocabulary because there will be later points in time where we're going to talk about how to multiply binomials, for example, and you need to understand what a binomial is for that to make sense. Okay, let's look at this polynomial. This is a little bit different because it's mixed up. We want to determine the degree of this polynomial. I'm just going to write in blue below this the degree of each term. 7x squared y is degree 3. 6 minus 6x squared yz is degree 4. 2 is degree 0. Minus 4y cubed is degree 3. So the biggest degree wins. So this is degree 4. So degree is the degree of the highest degree of any term in the polynomial. So you look at individual degrees and then pick the highest. Now this is a 4-term polynomial. Again, we don't have a special name for that. Let's talk about combining like terms. Like terms are terms that contain exactly the same variables raised to exactly the same powers. We can only combine terms if they're like terms, and we do that through addition or subtraction. When we combine the terms, we're going to add the coefficients and keep the variables. So for example, xy squared and 2xy squared are like, but x squared and x are unlike because they have different exponents on the x's. X squared, or sorry, x and x on this one, and then y squared and y squared on that one, same exact variables, same exact powers. Okay, so simplify by combining like terms only if you can. So minus 4y plus 2y, those are like terms, and I add their coefficients to get negative 2, keep the common variable. Z plus 5z cubed, cannot simplify. Those are not like terms. 15x cubed, subtract x cubed, is 14x cubed. I'm doing 15 subtract 1. This last one, I'm going to combine the terms that are like with each other. So 7a squared minus 3a squared is 4a squared. And then minus 5 minus 7 is minus 12. Now a lot of times at this point, people start to say, well, wait a minute, we just learned these exponent rules, and there was no such rule for exponents, and that is correct. Now let's talk about adding polynomials. To add polynomials, we're simply going to combine all like terms. So as an example, let's say I want to add the polynomial 3x minus 8. That's actually a binomial to the trinomial 4x squared subtract 3x plus 3. You'll notice that there's parentheses around each of these polynomials, but since there aren't any exponents or coefficients, numbers to be distributed, things like that, these parentheses really just serve to group things together, so I might as well just drop them. This is not a step you're normally going to have to show. You can just drop them in your head. And then I'm going to go about combining like terms. I'm first going to look for x squared terms because those are the highest degree. So 4x squared is the highest degree term. I'll write that first. There aren't any other terms like that. And then next, the x terms, or the degree 1 terms, there's a 3x and a minus 3x, so that's 0x, so really those are gone. And then the last thing are the constant terms, negative 8 and positive 3. Negative 8 plus 3 is negative 5, so I have 4x squared, subtract 5. Generally, when we write polynomials, we want to write them in terms of descending degree, which is why I wrote the x squared term first. Okay, now let's look at mixing up polynomials where we have mixed variable terms, so things that involve x's and y's. With these, we need to be a little bit more careful. So I'm going to start with the x squared y term and see if there are any other x squared y terms. There's one right there. So this is really an imaginary coefficient of 1 here. When I add them, I'm then going to get 11 x squared y. That's a degree 3 term. So now I'll move on to degree 2 terms. xy is a degree 2 term. So xy with xy added to xy gives me 2xy. And then finally, negative y with negative 2y gives me negative 3y. And notice again that this is written in terms of descending powers. So third degree term, second degree term, first degree term. To subtract polynomials, we just have to add the opposite of the second polynomial. Really what this means is we need to distribute the subtraction sign. So let's see an example. 7x subtract 8, subtract the quantity 3x subtract 12. So all I've done in the first line is copy this down, and I want to go ahead and distribute this subtraction. So in this case, the grouping symbols aren't meaningless. The grouping symbols on the first one don't have a number in front to distribute or any exponents, but on the second one, I'm actually distributing the subtraction or the opposite sign. So I can drop the parentheses on the first one, 7x subtract 8, but then it's going to be negative 3x plus 12. We'll do the x terms first. 7x subtract 3x is 4x. So we're doing those terms, and then negative 8 and positive 12 gives me positive 4. So similar example here, we're going to drop the grouping symbols on the first trinomial and then distribute the negative through the second. Notice that all the negative does is it just changes the sign on each term. Then I'll combine my like terms. My x cubed terms gives me negative x cubed. My x squared term is 10x squared. Then there's only one first degree or just x term, negative 7x, and one constant term, negative 3. So I get a polynomial with 4 terms in this case. Okay, similar idea here. I'm going to distribute the negative, so a lot of this is just more of the same. If I distribute the negative, I get plus y and plus 4, and I'll rewrite that as y plus 8. This one has a little bit of a mixture, the next one, the b part. The first set of grouping symbols has nothing special going on, so I just drop the grouping symbol. Then I distribute the subtraction in the second set, and the third set I can also drop because there's no negative or coefficient in front. So negative a squared, and 5a squared gives me 3a squared. Then my a term comes next, so minus 6a, and then my constant terms come last. So 1 plus 3 plus 7 is 11. The last remaining topic in this section is graphs of polynomial functions, and we'll save that for another day.